In this lecture, I'm going to provide you with a very brief introduction to Numpy arrays and what we can do with them. And to begin with, how do we go about creating Numpy arrays? We are going to work in this particular notebook called Numpy Intro, and that has already been provided to you. I suggest you type out all the code as I type along, and we are going to use the more practical applications of Numpy are going to follow on further in the course, but right now it is just important to get a hang of what Numpy arrays are and what they can do for us, and that is what the section will focus on. In order to use Numpy, first we need to import the Numpy package, and I'm going to import Numpy package as np, and essentially Numpy is allows us to basically use an n-dimensional array object or nd array, which provides a fast and efficient way of storing homogeneous data. And we can have an nd array with one dimension or one row, and these are known as rank 1 arrays, or we can have multi-dimensional arrays, nd arrays with more than one row. We can have things like 2-row arrays, 3-row arrays, and that's a very effective way of representing matrices. So first I'm going to show you how we go on to create NP arrays, and especially rank 1 NP arrays, and we can create this from ordinary lists as well. And just to demonstrate, so basically this is a list stored in the variable air1, and essentially this is just one list, and I can take this one list and convert it into a rank 1 array like so. So I'm going to use the inbuilt function called np.array, and because I've imported numpy as np, I'm going to put in np.array over here, and had I just put in import numpy, then I would have put in numpy over here. So let's just do this. Let us check its type by using the function type. So this is a numpy.nd array, and it's a rank 1 array because it just has one row, because I just put in one list. But we can even create a multi-dimensional nd array. Let us just run it, and this is a rank 2 array because we have 2 rows, and obviously this has 4 columns, and I can even make a bigger array than this. And remember, it's going to be a homogeneous array. So there goes. Sorry. So as you can see, this is a multi-dimensional array with 3 rows and 4 columns, and I can make my multi-dimensional arrays as big as I'd like them to be. And let us see what the dimensions of my array are. So over here I put in the name of my array, n array3 dot shape, and when I call the function shape from Numpy, it tells me that this array has 3 rows, 3L, and 4 columns. And I can even create some very specific kind of arrays. Say if I want to create a 2 by 2 array with zeros. Sorry, that was a problem with the brackets. I needed 2 arrays and as 2 brackets, and as you can see I get a 2 cross 2 rows and 2 columns full of zeros. And obviously you might wonder what is their purpose, but you know, if we want to carry out linear algebraic operations or carry out matrix manipulations, then the ability to create such customized arrays is very important and useful. And this is something that these are the kind of manipulations that we do end up carrying out occasionally in data science operations. So it is important to know what more we can do with our arrays and how we can extend the scope of Numpy to create such specialized arrays. And again, this gives me an ND array full of 5s. So it's a 2 cross 2 array, a multi-dimensional array or a rank 2 array, but full of 5s. And I can even create a 2 cross 2 matrix where the diagonals are 1 and the other values are 0. And again, these are the kind of arrays that one may end up using in different applications. So as you can see, in this case, the diagonal is 1, but the other values are 0, and it's a 2 cross 2 array, which I can even, let's see if I can just make it bigger. Let's just make it a 4 cross 4 array, like so. There. So all the diagonal values are 1, and all the other values are 0. And again, these are the kind of things that they do end up lending themselves to different matrix and linear algebra related computations. And right now we are just going to focus on looking at some of the functions that we can implement on Numpy based arrays and see how we can carry out mathematical operations on them, things like indexing, subsetting, or even applying some statistical operations on these. And that is going to come up in the next couple of lectures.